Okay, let's take another look at the rules for counting significant figures in calculations. So we've gone to great lengths to make sure that our measured values have the right number of digits because we're using a certain device that can provide us with a certain number of digits. And now we go to do a calculation, and our calculator gives us all kinds of crazy numbers, so we need to figure out how much to write down and how much not to. So there's two different rules. Depends on whether you're multiplying or dividing or adding or subtracting. So you need to keep the two rules straight. And I'm going to get a calculator handy so that we can do our math and see what's what. Okay, so you already have to know how to count significant figures because we're going to have to chop things off depending on how many significant figures we determine are in the numbers that we're using for the math. Okay, so let's start off with addition and subtraction. We saw this in the activity that we did, and basically if I'm adding two numbers that aren't the same precision, so that means that don't have the same level of certainty out into the decimal places, then we need to factor that in when we're reporting our final answer when those two numbers are added and subtracted. So if I have this number, 5,200, as one of my numbers that I'm going to add, and then I've got this number, 1.50. Now the rule for addition and subtraction is that I'm looking for the least precise number. So for this number, notice that when looking at the significant figures, we have the 5, the 2. These are trailing zeros, so at the end of the number, but there's no decimal point, so these are not significant. Okay, so that means that this number, we're certain up to the tens place. This number, notice that it has numbers in the tenths place and the hundredths place, and it is a total of 3 significant figures. So again, this trailing zero does count. That's why they bothered to write it down. That's the last place. That's where they stopped. They estimated it. So if there is a decimal point, we are counting this. Now anyway, when I add this up, if I punch these two numbers into my calculator will tell me 5,201.50. So your calculator just does the legwork of the math, but again, it's your job to know what numbers I'm allowed to report and which ones I am not. So if I add this together, this is what you get, but that's not the number you should report. The number that you should report is, again, whichever is my least precise number. So this number is only precise, only my estimation, my uncertainty begins in the hundredths place. So this is my least precise number to the hundredths place. This number is precise to the hundredths place. So that means that my answer actually needs to be rounded to the hundredths place. So in this case, now I'm not going to chop this off at 52 because that's not retaining the value that I mean, but I've got 5,200. So this is similar to that example we saw in class where we added the drop of water to the beaker, and it's not enough to register on the measurement device. Again, if I had something that was reading as this, and that 1.50 would register. Okay, so there's that. So again, for addition and subtraction, whichever number has my least precise place, that's where my final answer can go. So let's do another one of these so we can see. Let's stand over here now. Let's do 12.38 and 1.439. And we're going to add those two together, and the same rule for subtraction applies. So I'm going to put this in my calculator, 12.38 plus 1.439, computing, and there it is. We've got 3.819. So we're not interested at all in total significant figures for addition and subtraction. We are just interested in least precise number that we're using in the calculation. That's what our answer is allowed to have. So this number is precise to the hundredths place. This number is precise to the thousandths place. So that means that when I add these two numbers together, this is where I've got to stop. So the hundredths place is where this has to stop. Now notice the number directly to the right. So this is where I'm doing the chop. I look at this number to the right. That is, if it's 5 or above, you're going to have to round this last digit up. So 13.8, we're going to round that to 2. So 13.82 would be how you report that number. Okay. All right, let's take a look at multiplication and division. The rule is a little bit different. For multiplication and division, you are counting total numbers of significant figures. So if I have 15 times 2,440. Let's practice counting significant figures. So how many significant figures do you think are in the number 2,440? Take a minute, think about it. You can pause the video if you want. And notice, okay, so we know we count the non-zero digits. 1, 2, 3. This trailing 0, do we count it or not? Well, no decimal place, no count. So 1, 2, 3. That is 3 significant figures for that. Now this number down here, 1, 2. So that's easy, they're all non-zero, no questions. So that's 2 significant figures. The rule for multiplication and division is whichever of these numbers has the fewest number of significant figures, that's how many I report in my answer. So only 2 for this one. So when I multiply, let's see what we get. 2,440 times 15. My calculator, who doesn't know any better, says 36,600. And I know that from the rule I can only use 2 significant figures. So that means I'm going to start on the left-hand side of the number and count over. Those 2 would be significant. Now again, I don't want to put 36 on my paper because that's not the same thing as 36,000. So I need to round. Now, look to the number to the right. So the last number that I'm keeping, look to the right, that is 6. And the rule is if it's 5 or greater, we're going to round the last number we're keeping up. So this is going to be a 3, 7, and then we're going to put zeros here as placeholders for the rest of those places. So that's 37,000 would be how the answer would be correctly reported from this multiplication. The same rule applies for division.